Good evening, guys. Welcome to the video session on Mission Gate 2022 Electrical Engineering. And this is Bharat. So, in this video, we'll look into how to cover each topic through questions and important topics for power electronics subject. So, a bit about myself. I am Bharat Chandra. I graduated from IIT Bhubaneswar in 2015 from Electrical Department. I scored rank of 46 in 2021 GATE Electrical and also a rank of 39 All India wide in Engineering Services Examination 2020. So through GATE 2016, where I have gotten rank of 336, I went into IOCL, so where I worked for 3.5 years. So along with IOCL, I got selected into Power Grid Corporation of India Limited as well, and also yeah, ASC Bangalore MTech. So I chose to stay in IOC, and I've scored rank of 39 in AP Transco examination conducted in 2019. So this is a bit about myself, and this is our Telegram channel where you can join to discuss doubts with the topmost educators on this platform, and also you can discuss the doubts among yourselves. So this is about our Telegram channel, and the link is given here. You can click on it to join the Telegram channel. So this is Unacademy All India mock tests that have started on Jan 2nd. So on every Sunday there is a test that is conducted for every branch. So there are a large number of participants. If you so this is the last stage of your GATE preparation. So if you join these mock tests, so you will get a real-time idea of how it is going to be in the finals, and also whatever ranks that you are getting in these mock tests, that will reflect in the final examination as well, because these tests are free. You can enroll into these tests by using this QR code given here. So on every Sunday you will be having tests. That is Jan 2nd one test has happened, and on Jan 9th there will be second test, 16, 23 and 30. So on every Sunday there will be test for you. So it will be useful for revision, and also you can check your performance. So along with the ranks, you will be given how you have performed, and also analysis of the topics that you are lagging in, and also the topics you are good at. So please enroll for these All India mock tests by using the QR code that is given in the given here. So this is Unacademy Plus and Iconic. In Unacademy Plus, you will be getting access to all the live classes. So if you have subscribed to GATE classes, you will be getting access to GATE classes. If you are subscribed to Engineering Services, you will be getting access to ESC classes that is uploaded on Unacademy platform by all educators for your stream. That is, if you belong to electrical engineering, you will have access to all the videos regarding electrical engineering. So you will have weekly tests here, and the courses are very much structured because they are taught by topmost educators on this platform. Here you will have crash courses. Crash courses are for those who have less time for examination, and we have rank improvement batches. This rank improvement batches is for those who could not crack in the previous level, but they come to some extent in the competition. That is, say for GATE examination, if you are scored between 1000 to 2000 rank and you could not convert it into MTech or PSU, then you can join rank improvement batch, and also you'll have unlimited access. That is, there is no cap on the number of times you can watch the video. And coming to Unacademy Iconic, along with whatever you'll be getting on Unacademy Plus, you'll be getting a personal coach. That is, you'll have one-on-one guidance for preparation, and also the study plan is customized, and it will be tracked by the personal coach that is assigned to you, and you will have dedicated doubt clearing educators, and the notes will be specialized to you. It's not like the same notes will be given to everyone. It will be specialized for every student, and also you'll have study booster sessions where you'll be conducting regular workshops for rank improvements. This is Unacademy Iconic. So now coming to the subscription charges, for Unacademy Plus, you'll need to pay 2,704 rupees per month for 12 month subscription, and for 24-month one you need to pay 1967 per month. At the time of checkout, use my code KBC10 for extra 10% discount. And for coming to Unacademy Iconic, so you'll need to pay 4704 per month for 12 month subscription and 3467 per month for 24-month subscription, and use my code KBC10 at the time of checkout for extra 10% discount. So this is Unacademy Ask It Out. This is new initiative taken by Unacademy. So where you can ask unlimited doubts and you will get high quality video solutions in English and Hindi. You can ask doubts at any time in the portal that is given on Unacademy, and you will receive exact matches for those questions that you have asked, and you will also be getting assistance with your homework. This is Unacademy live mentoring product, that is Unacademy Iconic, as I have already told you earlier. So this is coming along with one-on-one mentorship. That is, each student will be given a mentor, and he will be personalizing your notes, and also he will discuss your doubts, and he will clarify your concepts, and also so that your exam strategy will be enhanced and it will be better. So use my code KBC10 at the time of checkout for extra 10% discount on Academy Iconic. So this is Unacademy special class features. So this is what you are seeing now is YouTube class. For special class, you need to go to Unacademy app, and you need to click on the link that will be given in this YouTube or on Unacademy. So whatever topics that I could not cover in the YouTube class, I'll cover those topics in special class. So the special class will be more interactive than the one that is being conducted now. There the interaction will be live, because students will be asking doubts. They'll put comments, and I'll be responding to the doubts that I have asked, and also we'll be conducting some fun polls, and also some polls regarding any topic or any question, and you can use raise a hand option to ask any doubt to the educator, and you will be getting customized notifications so that you will never miss a class. And at the time of at the end of the lesson, you will be getting lecture notes which you can download, and which will be useful for enhancing your exam preparation. So this is Unacademy special class, and this is Unacademy Ask It Out, as we have already discussed earlier. So you need to simply go to the platform, and you'll click on Unacademy Ask It Out. Click a picture of the doubt that you are having in whatever topic that you are stuck on, and you post the doubt, and you'll be getting solutions in the preferred language that you have clicked on, and you submit your question, and those questions will be answered by top educators. So now coming to the topic. So in this topic we'll be discussing about how to cover the syllabus through questions, or how to cover syllabus through important topics that have already been given in the GATE examination, previous GATE examinations, or also previous engineering services examinations. So by this time, I think you all might have completed the syllabus, or at least you have revised it once or twice. So there might be a chance of missing one or two topics by mistake, or by overlooking. So in this session, what we'll do is I'll try to cover every topic that has been asked in GATE examination till now in question form, so that whenever I am talking about the topic, or talking about the types of questions that might appear on the GATE examination, then you can recall if you have studied the topic earlier or not. So this will be useful, and you need not take any notes. You just have to listen to what I'm saying, and you just think if you have covered the topic or not. So coming to the syllabus that is given in the GATE examination, that is, you have static VA characteristics and gating circuits, and also you have firing circuits, and you have DC to DC converters, AC to DC converters, uncontrolled and both controlled rectifiers, and you have different commutation techniques. You have different types of factors coming in AC DC converters for continuous current flow, and also voltage source inverter and current source inverter, and also you have sinusoidal pulse width modulation. The thing is, AC to AC conversion is not given in the syllabus, but sometimes questions are being asked from the topic, but it is a simple topic only. There is not much complexity involved in AC to AC converters also. But for time being, let's not get into AC to AC conversion now. We'll look at that topic at the end. Look into the topic at the end. We'll come serial wise. First, we'll look into basics. That is, what are the different types of questions that can be asked from basics of power electronics. So the basic thing where you can expect some questions is the classification of power semiconductors or the semiconductors. Say coming to diode, it has uncontrolled turn on and turn off. SCR has a controlled turn on and uncontrolled turn off. Similarly, different semiconductors have different characteristics. Some of these semiconductors will be needing pulse requirements. Some have a bidirectional current capability. Some have unipolar voltage withstanding capability, and some others have unidirectional current capability. So you should know what type of semiconductor belongs to what classification. That is, if you have to classify based on current capability, so how you will classify? That is, what are the different semiconductors that will come under bidirectional current capability, and what are the different types of semiconductors that are coming under unidirectional current capability. Same with voltage withstanding capability. What are the different types of semiconductors coming under bipolar withstanding capability, and the semiconductors that are coming under unipolar voltage withstanding capability. And also, now what are the semiconductors that require continuous pulse gate requirement. So you'll need to know about every one of these. As you are listening to the class, try to take a paper and try to do this classification on that paper. Say you can write on the paper what are the different semiconductors that will have uncontrolled turn on and turn off, and controlled turn on and uncontrolled turn off, and controlled turn on and controlled turn off. This is one type of classification. So different types of semiconductors come under these three types. And what are the different semiconductors requiring pulse gate requirement? What are the different semiconductors requiring continuous gate signal requirement? This is one type of like classification. And the other classification is bidirectional current capability and voltage withstanding capability. So you need not know about the static and dynamic characteristics of all the power semiconductors, but you should know about uh, similarly placed semiconductors. That is, BJT, MOSFET, and IGBT. They are kind of similar, and SCR, GTO will have mostly similar characteristics. That is, you should be able to classify, and you need not to know in depth about every power semiconductor. Only power semiconductors that you need to know in depth are power diode, power SCR, BJT, MOSFET, and that's it. And coming to IGBT, you need not know in depth about IGBT, but you need to know what important things in BJT and MOSFET are into IGBT. That is, it will take some of the characteristics from BJT and some of the characteristics from MOSFET. So you should know what are these characteristics that have been taken from BJT and MOSFET into IGBT. So that is about this classification of power semiconductors. This classification is important, is not that important, but whatever importance it has, that will be there for one mark question only. If at all it is asked, it will be asked for one mark only. So this is about different types of the characteristics of different semiconductors. But as I have told you, you should know in depth about power semiconductor diode and transistor and its characteristics. It's not that it will be asked for 1 mark or 2 mark questions, but if you there are chances of getting a 1 mark question. If at all a question is asked from this topic, it will be from these characteristics only. So the classification that we have seen earlier, and you should know how the power semiconductor diode differs from high frequency semiconductor diodes that you will be seeing in analog electronics. So how it is different from the ones that we are seeing in analog electronics. Here the reverse breakdown voltage will be more, and also the doping will be less, so that depletion region will be more, so that the breakdown voltage will be more. So that's the major difference between these two. So if at all a question is asked, there are chances that a question might be asked from this topic. And also along with this we have reverse recovery time. So you might have looked into this formula that reverse recovery time is equal to square root 2 times charge into di by dt, no 2 times q into 1 plus s by di by dt. So the s being safety factor or softness factor. So you need to know what s is, that is s is the ratio of what and what, and you should be able to substitute these things properly to get reverse recovery time. Or sometimes you might be asked to find out reverse recovery current. So you should be able to tweak this formula so that you are getting the answer that is being asked to you. So it is better you look into the graph of switching characteristics of these diodes and how this formula is obtained, because this softness factor is ratio of that is what you say T5 by T4, that is once that you can see in the graph of turn off transients. So time to reduce the carrier's density at both junctions to 0, that you will call T5, and T4 will be at what time it is reverse bias. So you should most of the times the softness factor will be given. If the softness factor is not given, you should be able to take these the sum of these times or the ratio of these times if the graph is given. So this is about reverse recovery time. So mostly direct formula question will be asked, but for safe side you should know how this formula is derived and what the snapness or softness factor is, and it is the ratio of what and what. So till now we have looked into two different things. One is the classification of different types of power semiconductors and this reverse recovery time. And in this reverse recovery time we should also look into the softness factor. So this is about this power diode. And coming to power BJT, it is not that important because BJT topic is already covered in analog electronics. There is not much emphasis in this topic in power electronics. But the question that you might expect maybe may come from this total turn on time and total turn off time. That is, you might be given 4 different times, that is delay time and rising time, and also you will be given TS, that is storage time, and recovery time. So you might be asked to find out what T on is and what T off is, or you might be asked to find out what the switching frequency is, or you might be asked to find out what is the turn on time or T on by total T. So in order to know total turn on time and total turn off time, you should know what part of time is coming under on time and what part of times is coming under turn off time. That is, delay time and rise time will come under T on, and storage time and fall time will come under T off. From this you can find out the duty cycle, and also you can find out switching frequency as well. So it is kind of important with respect to engineering services examination, but it is not that relevant for gate examination. But you should look at a safe side, and you should play it safe. For being safe, you should know about these factors. So you'll never know what type of questions they might ask in the gate examination. And coming to the most important type of question that you might expect in the gate examination is from this whatever power semiconductors topic is the switching frequency or the energy loss that has happened during turn on time and turn off time based on the graph that is given to you in the examination. So you will be given VCE and IC graph. So during turn on, VC will fall, and during turn off and VCE will gain, and IC will take reverse characteristic. So you will be asked to find out what is the amount of energy that is lost during this switching, energy lost during one cycle, or energy lost during turn off, or energy lost during turn on. So most important thing is looking into the question for details. So you should look at the question to find out if it is asking you to find out energy loss during turn on or turn off. If it is turn on, you should look into the part of graph where it is mentioned that T on is there. So go to that part and take equations for IC and VCE and integrate it from 0 to T on for with respect to dt, and whatever energy that you are getting, watt second that you are getting, that is the energy loss during turn on. So if you are asked to find out turn off, energy loss during turn off, go to the part of graph where T off is mentioned and take equations for VCE and IC and integrate it from 0 to T off with respect to dt and find the energy loss. So if you are asked to find out the total energy loss, then you have to add energy lost during turn on and energy lost during turn off, and you should add both of them. So this is total energy loss. So now how you will find out a total power loss. So if you have to find out total power loss, you will switching frequency will be given, or you will need to find out switching frequency, and from the switching frequency you need to find out the total power loss. So that's it. So this is one of the most important topics, or are the areas where you might expect a question from power electronics in the gate examination. I think last year or this year one question has appeared from this topic. So if you are given a graph of VC and IC of a power BJT during turn on and turn off, that is during one full cycle, and if you are asked to find out power loss or energy loss, look at the question. If it is asking you to find out energy loss during turn on time or turn off time, or total energy loss in one cycle. So these are three different questions that you might expect. And also from total energy loss, you can find out average power loss from given switching frequency. Or if average power loss is given and you have found out a total energy loss during one cycle, you can find out the switching frequency. So you should be able to play with the formula. So this is about power BJT. Power MOSFET is not that important for gate examination. It will be covered in analog electronics topic only. So mostly the questions that will be asked will be based on the power loss during switching of BJT or MOSFET, because semiconductor devices, the most important thing is the power loss. Power loss should be limited to a given number, so for safe operation. So you should be able to design or model your MOSFET or BJT so that the power loss will be less, because the switching frequency will be more in MOSFETs or BJTs. So power loss during this switching will be more. So you should be able to keep that power loss to a limit so that it will be useful in high frequency operations. So sometimes you might be asked to find out on state losses and off state losses that you can do using formulae, and you should know about basic things regarding MOSFET and BJT. So for this you need to have a conceptual understanding of how BJT and MOSFET operates from analog electronics topic. So from analog electronics topic you need to know how these operate, and what are the basic things that you need to remember if you are given any 1 mark problem or 1 mark statement problems in power electronics. So till now we have discussed about power BJT. What is the question that you might expect from power BJT, and power diode, and also the classification of these semiconductor devices. So another basic thing or another basic that is required for power electronics subject is diode rectifiers. So the basic mistake that we do while preparing power electronics is, at first we'll go into the semi controlled rectifiers, or or you know these are uncontrolled rectifiers. We'll go into controlled rectifiers, and we'll try to get all this alpha and that is the conduction time and thyristor firing angle all into our mind, and we are confusing ourselves with load of formulae, and we are trying to, and with that we are forgetting the basic formula or basic things that we need to solve any problem. So you should be good at diode rectifiers with resistance load. So after that we can go into three-phase diode rectifiers, and after that we should go into silicon or you say fully controlled rectifiers. So first we should look at uncontrolled rectifiers for resistance load and for inductance load, and for three-phase same resistance load and RL load and inductance load. And after that we can apply the same things that we have learned here in the diode rectifiers into silicon rectifiers. So first we should know how single phase half wave rectifier operates for R load. So you should remember the formula for average and RMS value of output voltages and RMS values of load currents. So if you know about output voltage, then you can find out output current, because the load is simply R. And you should know about the thing is peak inverse voltage is here, and from what time to what time peak inverse voltage is happening. That is for if you look at a single phase half wave rectifier, that is from pi to 2 pi. You will have peak inverse across the diode. So based on this, there are some basic questions that will be asked in the gate examination. So from power electronics, even the 2 mark questions will be simple, and they won't require any challenging solutions or so. They are pretty much basic only. But the thing is, most important thing is understanding what is being asked in the question. So questions are simple only. If you know the concept, then you will be able to answer the question very easily. So look at the question, take your time, and then try to answer, because the questions the misconception that students have regarding power electronics is the topic is the subject is very difficult, and it is very difficult to answer power electronics questions. But it is not the case in a gate examination. Almost every question that is asked in the gate examination from power electronics can be answered easily, and can also be answered in very less time. It will take very less time when compared to machines or power systems. But only important thing is you should know what formula to apply. By looking at the question, you should know what formula you should apply and what is the approach that you need to follow. Coming to machines and all, the most difficult thing is calculations. There you know the approach and everything. The models also will not change. They are not conceptual based, but there the calculations are difficult. That's why there are chances of losing marks are there in power systems or power or machines. But coming to power electronics, the method that you need to apply for each question differs, and that is the most challenging thing in solving power electronics questions. So you should take time and take time to answer. It's not like you can go blindly and you can answer based on the assumptions that you have. Should look at the question carefully. And till now we have looked at single phase half wave diode rectifier with R load. Now you should know how to solve the same for an L load. If you have good grip in R load and L load and RL load for diode rectifiers, then it will be easier for you while solving SCR questions. Here the voltage across diode will be 0 because, and also the RMS value is not I naught by 2, unlike R load half wave rectifiers. It will be I naught by root 2, and these are all basic things that are already covered for you in your classes. So this is just pretty basic, but you should know the graphs of single phase half wave diode rectifier with R load, L load and C load, and from those graphs you can answer any question that is asked in the examination. Say if you know about these graphs, say for single phase half wave diode rectifier with C load, then you will be able to answer what is the maximum output voltage across the capacitor. So that is VC, that is VM, because once it is charged to VM, the diode will be off and the output voltage will stuck at VM forever. And also you might be asked to find out what is the RMS voltage across diode. There are many different questions that you might be asked about. So you should know, once you know about the graphs, how they work, then you can answer any type of question that is asked for you. And also the RMS value of diode is not VM or 2VM. It is different from what you are getting in R load and L load questions. So this is basic, but you need to know about these graphs. If you know how the voltage across each source or each diode or each capacitor varies at different times, then you can answer the question very easily. So this is about single phase half wave rectifiers for R load, L load and C load. Now after this you should look at single phase half wave rectifier with RL load. So at what time RL load will give you two different things, that is continuous conduction and discontinuous conduction. So discontinuous conduction will have one beta where the current will be 0, but since that is transcendental equation, you will never get this extinction angle which will normally denoted by beta. So there are no chances of question being asked from this particular thing. So what the examiner might do is they will give you the value of beta, and you might be asked to find out the value of output voltage or output current based on that beta and the value of R. But a thing that you should remember is the average value of output voltage or output current will not depend on L. It will solely depend on R and beta. So that is about RL load. So now RL load might have continuous conduction or discontinuous conduction. So for that, what we'll do is we'll use freewheeling diode for continuous conduction. So when we use freewheeling diode, then the output voltage will be same as that of that is half wave diode rectifier. The output voltage will be same as that of half wave diode rectifier, but the thing is freewheeling diode will conduct for some time. So sometimes you might be asked to find out for what amount of time that freewheeling diode conducts, which is given as pi minus beta, beta minus pi. So the beta will be given to you, and after pi, after 180 degrees, current will start flowing through the freewheeling diode. So this is one more type of question that might be asked for you. So most important thing in power electronics is knowing about how these graphs work and how to draw the graphs based on the circuit that is given to you. So you cannot remember everything in the examination, you cannot reciprocate everything in the examination. So important thing is how the circuit works for every point of time, that is for 0 to pi by 2 how the circuit works, and pi by 2 to pi how the circuit works, and for one cycle how the circuit works, that you should know. And till now we have looked into R load, L load, C load, and RL load for continuous and discontinuous conductions, and RL load with a freewheeling diode. Now we will look into RE load. What this RE load gives is you will have two more angles, that is theta 1 and pi minus theta 1, for which this battery will come into picture. RE load is nothing but the rectifier feeding a battery, or battery feeding a rectifier, that is you might call it inverter. So this is kind of complicated in that you might be asked sometimes to find out power delivered to load. So the basic mistake that we do most of the times is we'll find out uh, I RMS at the output, and we'll take I output RMS square times R, and we'll give this as power delivered to load. But the power delivered to load is E times I naught plus I naught RMS square times R. That is there is some current, average current, that is flowing through the battery, and some current, RMS current, that is wasted in the resistor. So you should be able to take both into consideration, then only you will get the power across load. So this is one more thing. And you might be asked to find out supply power factor. Supply power factor can be obtained from power delivered by the source and power delivered to load. Since the power is conserved always, so you can take Vs I source times RMS into cos theta is equal to power delivered to load, that we have already discussed earlier. From this equation we can get the supply power factor. So mostly it all boils down to drawing the graphs. So from the graphs you can get everything. So this RE load is more important for 2 mark questions. So you might be asked to find out the average current across diode, or average source current, or the power supplied to battery, or power dissipated in the resistor, and everything. And sometimes you might be asked to find out supply power factor. Last year, I guess, we were asked to find the power peak inverse voltage question was given, which is pretty easy. So, but for RE load, if peak inverse voltage of diode is asked, that is source voltage plus peak of source voltage plus this battery voltage, whatever is there, that is the peak inverse voltage. So you should what you can do is you can draw different configurations on paper, and for every configuration you try to draw the graphs and how to calculate output voltage, output current, and peak inverse voltage of diode, and how to calculate rectifier efficiency, and how to calculate a supply power factor, and when the diode will start conduction for RE load, and when it will stop conducting, and everything. So this is one more thing where you can focus how to calculate RMS value of currents and all. Don't try to remember the formula for RMS values of currents. One more important thing is the value of RMS of these charging currents was not that frequently asked in GATE examination, because it involves complex calculations. There are so many squares and square roots and sine, cos, everything is there. So there are less chances of questions being asked from this. Mostly you will be asked questions about average power, or average value of charging current, because it doesn't involve squares and square roots. So that is one thing. And just like you have studied now about we have discussed now about half wave rectifiers and half wave rectifiers with different configurations, that is R load, L load, RL load, capacitor load, and RL with freewheeling diode, RL with continuous and discontinuous conduction, and all. So just like this, we have single phase full wave bridge rectifiers, full wave diode rectifiers, and there are many other things which are kind of equivalent. Once you know about how to solve the problems with respect to half wave bridge and half wave rectifiers, then you can easily solve full wave rectifiers. So there are some small difference between full wave midpoint diode rectifiers and diode bridge rectifiers. The small difference is regarding transformer efficiency, and also the rectifier efficiency and the peak inverse voltage. These things will vary in these two configurations that you need to know. And single phase full wave diode rectifier with RLE load is there. Mostly what happens in the examination is load current will be given continuous. Look at the question, if the load current is given continuous or not, or continuous, not continuous, sorry, constant load current or not. If the load current is given as constant, then everything changes, because in that case they are not only looking into the primary, that is source frequency currents, they are looking at harmonic currents as well. Only when primary frequency currents are added to harmonic currents, then only we will be getting constant load current. If constant load current is asked, then our problems will become easier. You need not do all these squares and square roots, or otherwise integrating over one full cycle and all. If the load current is given constant, then we have a Fourier analysis for that. From that we can obtain the answers for the questions. But if it is not given in the question that it has a constant load current or something, then we should go for these integrations and all. So it depends on the question. That's why look into the question for the details. So these details will save you in obtaining the final answer. Till now we have discussed about single phase full wave rectifiers for R load, L load, RLE load and everything. That is for sinusoidal output voltages, you may say. But for there are some performance parameters that for constant output voltages and currents, for constant output currents, that we'll look into afterwards. So coming to these factors, so you should know about 2-3 important factors. The rest of the factors are not that important. That is, input power factor is important. Input power factor is different from normal power factor. So that is one thing. And displacement factor and current distortion factors. These 3 factors you should not confuse in between, and you should not put wrong option. This is one thing. And other things being whatever I have told you now, they are input parameters. Output parameters are rectification ratio and ripple factor and transformer utilization ratio. These ratios are not important. The only important ratios are the input ratios only. Till now we have looked into single phase rectifiers. Now we'll look at 3-phase rectifiers. 3-phase rectifiers are not that important for gate examination. Mostly the questions are being asked from single phase rectifiers only. Whatever 3-phase rectifier problems are there, that will be asked mostly based on formulae, or maybe you might be asked to find out different conduction times, like for what time this diode has conducted, or what is the average current for given a constant load current. And one more thing is peak inverse voltage across diode. That is kind of tricky for this 3-phase half wave diode rectifier and full wave diode rectifier for both midpoint and bridge rectifiers. So this is kind of tricky, but you should know to solve the questions from this. And output RMS currents or output RMS voltages are pretty straightforward. So you should know how to take square roots and squares of all these, because for a 3-phase diode rectifier with R load, there is not much complication. When the load involves battery and resistor, then the solution becomes complex. So what they'll do is, if the question is involving battery and its internal resistance, the output current will be constant only. If it is if the one who has set the question paper doesn't want you to trouble much, or usually he won't trouble you much, because the calculator given in the gate examination is difficult to use. So if you are given only R load, then you will be asked to, you might be asked, or there are high chances of you being asked to find out VRMS and use these tough calculations and finding V squares from pi by 6 to 5 pi by 6, and you should integrate with respect to theta, and all these things you have to do. But if the question is involving any battery and its internal resistance, then you need not, mostly you will not be asked to find out all these. The current will be given constant. So two things that you have to take out of this: if the load is only R load, then the load current will be kind of sinusoidal. So finding RMS value or average value of the current across the output will be tricky. But since it's involving only resistance, finding output current or output voltage will be easier. If the output is involving battery and its internal resistance, then the question becomes tricky, but it will be given in the problem that the current is constant load current. So you should know how to take RMS values of these source currents and load currents. Even in these three-phase half-wave diode rectifiers, the most important things are taking graphs. That is, for 0 to 360, you should divide it into 6 parts, and for each part you have to draw the graph, and you should see how the circuit is behaving, and based on that you will be drawing the graph, and also based on the graph you will be solving the problems. So as far as I know, the only most important thing from this topic is finding peak inverse voltage, and also from what time period to what time period each diode is conducting. Based on that, we can calculate VRMS, V output, IRMS, I output as well. But they won't be asked in the gate examination, which is my gut feel. Most important thing is maximum voltage across diode. So that is about three-phase rectifiers. Three-phase rectifiers are not that important for gate examination, but if at all a question is asked from this, it will be mostly about output output voltage, average output voltage, and average and RMS output voltage, or average output current, and average RMS output current. These four things that you might be asked, and other thing being peak inverse voltage across the diode, and also diode RMS voltages and diode average currents are also there, that you can take a look into, but it is not that important for gate because they are tricky. They involve complex calculations and also very in-depth understanding about these diode circuits. Till now, I haven't ever seen any question from this topic. Mostly you'll be asked to find out average output voltage or RMS output voltage, or average current, or RMS current. That's it. So one more thing is, mostly whatever the voltage that you are given in the examination, that is line to line voltage only. If it is mentioned, that is fine. If it is not mentioned, you take it to line voltage only. So that is about semiconductor diode rectifiers and all. So now we will look into thyristor circuits. So thyristor circuits, they involve two things. One is regarding that three-phase configuration or single-phase configuration, these peak inverse voltages, output RMS currents and all, and the other thing being theory regarding SCRs, and what are the different firing circuits and different gating circuits for SCR. So for SCR, you should know about in depth, because there are times where questions were asked from basic operation of SCR. That is, it will have an anode, a cathode, and a gate, and it will have 3 junctions, and from that you can solve these problems. And also you should know about holding current and latching current, and how it operates for given reverse voltage, and how it operates for given forward voltages, and what are the different modes in its operation, and how it operates in each different mode. And now coming to the most important part from SCRC is finding latching current. That is, there are different types or different modes of turning on an SCR. Most important are with respect to gate being giving it gate pulse current to turn on this SCR. So we'll be given the inductance and resistance. We'll be asked to find out minimum gate pulse required for different configurations. So for RL load, we'll have one thing, and based on the resistance, the required gate pulse width changes. So latching current and holding current, as I have already told you, they are important. So that is one more thing. One more thing being, sometimes you will be given the characteristic gate cathode equation. From that, you'll be asked to find out the resistance to be connected in series with SCR gate to turn on the SCR. And you might be asked to find out triggering frequency that is required, and also you might be asked to find out the duty cycle of this triggering pulse. These questions you can see in Bimbra, PS Bimbra. This is important. Whatever equations that is given to you, so you will be given Vg is equal to 2 plus 2 Ig or 2 plus 3 Ig something, and you will be given some gate drive power, and you will be asked to find out Ig or the gate current first. So you will have one quadratic equation, that is Vg Ig is equal to whatever peak power that is given. You will equate it to that, and you will solve this, and you will get Ig. From that Ig, you will find out whatever Eg gate voltage, source gate voltage, and from that you can find out all the different parameters and also duty cycle and all. And one more thing is surge current rating of SCR. This is important for ESC, on the engineering service examination only, not important for gate examination. And the design of snubber circuit, gate protection and everything. One more thing is you have heating and cooling of SCR, where these whatever sinks are, these junctions are modeled as resistances. So from this you can get average power. This is again not that important for gate examination. And one only thing which is important for gate examination is the series operation and parallel operation of SCRs. So you will be needing static equalizing resistance for series operation, and also some capacitances for parallel operation. So you need not know how to derive that formula, because the derivation is important for ESC mains and not for gate. If you can remember that formula, you can solve these problems if it is given in the gate examination. Apart from this formula, there are not much important things in this topic, so you can skip that. So as I have told you earlier, these junctions are whatever heat loss between one junction to another junction is there, that heat loss is modeled as a resistance. So based on this series circuit, you can find out different average powers with respect to string efficiency of SCRs. So this is one more important topic for gate examination. And coming to firing circuits, these again are not that important for gate, if at all. Thing is, you will be given a circuit in the gate examination. You will be required to use your network analysis and also your power electronics analysis in solving the problem. It's not like you have to know everything that is given in PS Bimbra or whatever textbook that you are referring to by heart. So if you know about how the circuit works, you'll be able to solve this formula. So UJT, that is one more technique to turn on SCR, but it is not given in the syllabus, so it is not important for GATE examination. So thing is, you should know how the different semiconductor devices work. That is in general, or you may say the basic things that are required for the semiconductors to operate. It's not like you should know everything in depth by heart, but it's just pretty basic. One more type of problem that you might be asked will be static IV characteristic of thyristor will be given, and you might be asked to find out average power loss in the thyristor and also average RMS current rating. This is again one more topic where you might expect question is. So in this topic we have seen some things regarding power electronics. In the next lecture we will look into the topics that we have left, that we have not covered in this lecture. So what we have covered in this lecture are the basic static VA characteristics and how different semiconductor devices are classified, that is unipolar and bipolar, and the devices that accept current only in one direction and accept currents in both directions, and devices that need that are uncontrolled in both on and off, and controlled in on and uncontrolled in off, and controlled in both on and off, and devices that require gate power, that is gate current, devices that do not require gate current. That is one thing, and other thing is BJT, power BJTs are given, and the graph for VC and IC is given. Then how to find out energy loss for on, for off, and total energy loss, and average power loss, and also switching frequency and all. Same applies for MOSFET as well, and also different times you should know. That is on time, off time, storage time, delay time, rise time, fall time, and all. And also different diodes, different types of diodes, that is diode circuits, that is single phase R load, RL load, L load, RE load, RL load with freewheeling diode and without freewheeling diode. Same with three phase as well. So till now we haven't looked at the constant current modes. For constant current mode, the things will change. This is whatever we have discussed. This is about sinusoidal currents. That is, there is harmonics are not considered, and also this either one requires knowledge of graphs, but for this this is basic. If you know about this in depth, the rest of the ones with constant current will become easier for you. So reverse, that is peak inverse voltage, is important, and the way you calculate output RMS voltage for each configuration is important. Also output average currents, output average voltages for every load, R load, L load, RL load, RE load. For RE load you should know about the starting angle and extinction angle, and the beta for RL load and all. So maybe you can open a paper and try to draw all these different configurations, and try to draw graphs of how currents vary during one full cycle. That is how currents vary across the load, how current and voltage vary across the diode, and when is the peak inverse voltage happening, and what is the amount of peak inverse voltage for every configuration that we have discussed till now. Half wave rectifier, full wave rectifier, and also for both single phase and three phase. That is four rectifiers we have covered now. That is for R load, and we have another for L load, another for RL load, another thing for RE load, another for RL with freewheeling diode. So there are many different combinations for which you can draw these graphs, because I am emphasizing more on these graphs, because if you know how these graphs work, or how to draw these graphs, then it will be easier for you to calculate the RMS voltages or output average voltages. So in the next topic, we'll discuss about how to calculate different factors, or what are the important questions regarding these factors with respect to SCR circuits and DC-DC, and also inverters and pulse width modulation and all, and also different computation techniques. Thank you.